A rare visitor from deep space is racing through our solar system at unprecedented speed, and NASA's latest data has left scientists questioning everything they thought they knew about cosmic visitors. 3I Atlas, the third confirmed interstellar object ever detected, exhibits characteristics so unusual that some researchers are considering the unthinkable. Could this ancient wanderer be more than just a natural comet? As we uncover its secrets, the implications for humanity's understanding of our place in the universe become increasingly profound and, honestly, pretty terrifying. The breaking discovery. On July 1, 2025, the NASA-funded Atlas Asteroid Terrestrial Impact Last Alert System Survey Telescope in Rio Hurtado, Chile, first detected an unusual object later confirmed as 3I Atlas. This interstellar comet was initially spotted at a distance of over 4.5 astronomical units from the Sun, activating alarms across the global astronomical community. Its detection marked the third confirmed interstellar object ever observed passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. The initial observations revealed a hyperbolic trajectory with an incredibly high orbital eccentricity of 6.141. The highest ever recorded for any known interstellar visitor. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object, but a rare visitor that had been journeying through space for billions of years. The object's incoming velocity of 58 kilometers per second relative to the Sun marked it as the fastest interstellar object ever detected, surpassing both Oumuamua and Borisov by significant margins. From the outset, astronomers recognized that 3I Atlas was fundamentally different, initiating a worldwide mobilization of observatories dedicated to tracking this cosmic traveler and unraveling its profound mysteries. The discovery story. Between June 25 and June 29, 2025, the Atlas system had been gathering precursor observations that would later prove crucial in understanding 3I Atlas's trajectory and properties. These pre-discovery images, retrieved from survey archives and including work by the Zwicky Transient Facility at Palomar Observatory in California, helped confirm the object's interstellar path. Sam Dean, an amateur astronomer, contributed critical early tracking data, noting that the comet's trajectory through dense star fields near Sagittarius made early detection extremely difficult. The object's path passed through crowded cosmic neighborhoods, where countless background stars created a celestial camouflage, explaining why it had escaped discovery earlier despite being in the inner solar system for weeks. John Tonry, principal investigator of the Atlas project, immediately coordinated with facilities across the globe to confirm the object's characteristics once it was detected. The challenge of identifying 3I Atlas stemmed from its approach through regions where most sky surveys don't venture due to the overwhelming stellar background. This cosmic game of hide-and-seek had been ongoing since June 14, 2025, when the earliest pre-discovery images show the object silently crossing space. The rapid coordination between professional and amateur astronomers from multiple continents underscores the unprecedented global effort invested in monitoring this mysterious visitor. A stranger in our midst. 3I Atlas exhibits characteristics so unusual they continue to baffle the scientific community and challenge our understanding of natural cosmic objects. Traveling at a staggering 61 kilometers per second relative to the Sun, it far exceeds the speeds of its predecessors like Oumuamua and Borisov, making it the fastest interstellar visitor ever recorded. Its brightness is particularly notable, with a distinct coma and tail forming as solar radiation heats its surface, causing ice sublimation that creates spectacular visual displays. David Jewett from the University of California, Los Angeles, noted that the comet's tail and dust emissions provide rare data about materials formed in distant star systems billions of years ago. Perhaps most puzzling is that its trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun, an alignment with merely a 0.2% probability of occurring by random chance. This mathematical precision has prompted serious speculation about whether the object's path represents natural celestial mechanics or something far more intentional. The combination of unprecedented speed, unusual brightness, and statistically improbable orbital characteristics raises fundamental questions about whether 3I Atlas is truly a natural object, or represent something far more enigmatic that challenges our basic assumptions about interstellar visitors. The predecessors. So, to really understand the true significance of 3I Atlas, we have to take a look back at the two remarkable interstellar visitors that came before it, each bringing their own, well, unsolved mysteries. The first, 1I, Oumuamua, was discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii. It immediately stunned the scientific community with its elongated cigar-like shape and honestly, its completely unexplained acceleration away from the sun, all without any visible signs of outgassing. This mysterious acceleration just defied conventional physics and sparked some pretty intense debate about whether the object could be natural or possibly artificial. Then, in August 2019, amateur astronomer Gennady Borisov discovered 2I Borisov from his observatory in Crimea. This one proved to be a more traditional active comet, showing the typical outgassing behavior you'd expect from solar system visitors. The stark differences between these two ancient travelers, one mysterious and possibly artificial, the other conventionally comet-like, have really intrigued astronomers worldwide and, more importantly, set important baselines for comparison. Mark Norris from the University of Central Lancashire has pointed out that 3I Atlas, being the largest and brightest interstellar object yet discovered, gives us unprecedented opportunities to compare and contrast with its predecessors. This growing catalog of interstellar visitors is finally starting to reveal patterns that could unlock secrets about the diversity, origin, and true nature of these cosmic wanderers from distant star systems. The cosmic journey. 3. I Atlas's trajectory through our solar system, honestly, follows a carefully orchestrated path that gives us optimal opportunities for comprehensive planetary observation. The object will reach perihelion on October 29, 2025, getting close to the Sun at about 1.36 astronomical units, positioned just perfectly between the orbits of Earth and Mars for extended observation. At perihelion, it'll hit maximum speeds of nearly 68 kilometers per second, which really shows off the extreme velocities you get with interstellar travelers. Paul Chodas from NASA's Center for Near-Earth Object Studies has calculated that while the comet poses no threat to Earth, keeping a safe distance of at least 1.8 astronomical units, its path brings it remarkably close to Mars, Venus and Jupiter during its trip through the solar system. The precision of this trajectory is pretty striking. It allows close approaches to 3 major planets and provides optimal vantage points for studying inner solar system dynamics. Karen Meech from the University of Hawaii emphasizes that this close approach sequence is, honestly, an unprecedented opportunity to see how an interstellar object interacts with different solar environments and planetary gravitational fields. The object will pass just 0.19 astronomical units from Mars on October 3rd, followed by a 0.65 AU approach to Venus on November 3rd, creating a sort of reconnaissance pattern that seems almost deliberately designed for a comprehensive solar system survey, rather than just a random cosmic passage. A scientific goldmine. 3I Atlas, really represents an unprecedented scientific treasure trove for astronomers and planetary scientists who are studying materials from beyond our solar system. With an estimated diameter somewhere between 0.32 and 5.6 kilometers, it's significantly larger than previous interstellar visitors. That means it actually allows for detailed study of its composition, structure, and evolutionary changes as it interacts with solar radiation. The Hubble Space Telescope, operated by teams led by David Jewett at UCLA, has been tracking dust emissions and nuclear activity, revealing ongoing sublimation of ancient ices and continuous dust release from the object's surface. These observations are providing crucial insights into the comet's volatile content and primordial materials, likely preserved for over 7 billion years, predating our entire solar system's formation. Stephanie Malam from NASA Goddard Space Flight Center is coordinating advanced spectroscopic observations using the James Webb Space Telescope to, hopefully, identify complex organic molecules and unusual isotopic signatures that could reveal the object's stellar birthplace. Current analysis has already confirmed the presence of water ice, both as solid grains and vapor, along with hydroxide ions, suggesting a water-rich composition that's typical of objects formed in the outer regions of planetary systems. The ongoing research aims to characterize the complete molecular makeup, including potential carbon monoxide, methane, and complex organic compounds, offering rare glimpses into the chemical building blocks and formation processes of distant star systems. Unanswered questions. Despite intensive global observation campaigns, 3I/Atlas continues to harbor profound mysteries that challenge our fundamental understanding of interstellar objects and their origins. The object's precise nuclear size remains frustratingly uncertain because the surrounding active coma obscures direct measurements of the solid nucleus, which complicates crucial density and mass calculations needed to determine its true composition and internal structure. While spectroscopic analysis has confirmed the presence of water ice and organic compounds, the detection of other expected volatiles like carbon dioxide and carbon monoxide remains elusive, raising questions about the object's formation environment and preservation mechanisms during its multi-billion-year journey through space. Julia de Leon from Spain's Instituto de Astrofísica de Canarias emphasizes that the object's unusual thermal properties and outgassing patterns don't conform to standard cometary models, suggesting either exotic compositions or structural characteristics not found in typical solar system objects. Perhaps most puzzling is the object's remarkable preservation state. How materials billions of years older than our solar system could remain so well preserved and chemically active after eons of exposure to cosmic radiation and interstellar conditions. Some researchers are beginning to debate whether the object represents a completely natural phenomenon or exhibits features that might indicate artificial construction or enhancement, a possibility that would fundamentally challenge our understanding of what's possible in the cosmos. The alien question. The possibility that 3I/Atlas represents humanity's first encounter with extraterrestrial technology has, sparked some pretty intense scientific debate and forced researchers to confront some uncomfortable questions about the object's true nature. Avi Loeb, who's Harvard's Frank B. Baird Jr. Professor of Science, has really emerged as the most prominent advocate for seriously investigating artificial origins. He cites the object's statistically improbable trajectory, its unprecedented velocity, and honestly, its unusual structural characteristics as evidence that, warrant extraordinary investigation. Loeb's analysis suggests that the mathematical precision required for 3I/Atlas's path, which actually provides optimal reconnaissance opportunities while passing close to multiple planets, exceeds what we'd reasonably expect from random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide, specifically searching for signs of artificial construction or technological signatures. However, mainstream astronomers like Sarah Seeger from MIT and Alan Fitzsimmons from Queen's University Belfast urge extreme caution, emphasizing that extraordinary claims require extraordinary evidence, and that natural explanation should be exhausted before considering artificial hypotheses. The scientific community now finds itself balancing healthy skepticism with the recognition that, if 3I/Atlas does represent extraterrestrial technology, the implications for humanity's understanding of our place in the universe would be, revolutionary, and potentially terrifying in their scope and consequences. Observing the visitor. Astronomers across the globe have mobilized an unprecedented array of telescopes and instruments to study 3I/Atlas as it journeys through our solar system, creating the most comprehensive interstellar object observation campaign in history. Major facilities including the Very Large Telescope in Chile, NASA's Hubble Space Telescope, and the revolutionary James Webb Space Telescope are collaborating to collect multi-wavelength data that could, hopefully, unlock the secrets of this cosmic visitor. Michelle Bannister from the University of Canterbury notes that this coordinated effort involves over 50 professional observatories and, honestly, numerous amateur astronomers contributing observations and analysis. The Southern Astrophysical Research Telescope has been conducting detailed spectroscopic analysis to identify specific molecules and compounds in the object's coma and tail. Ground-based facilities like the Gemini Observatory and Keck Observatory in Hawaii are providing continuous monitoring of brightness changes, rotational periods, and thermal emissions that reveal internal heat distribution patterns. Canada, France, Hawaii telescope observations have captured deep images showing faint cometary activity even at great distances from the Sun. This international collaboration represents a new model for rapid response astronomy, with data-sharing protocols that allow real-time analysis and immediate follow-up observations when unusual phenomena are detected, ensuring that no critical information about this rare interstellar visitor is lost. Dawn of a new era. The detection and intensive study of 3I Atlas heralds the dawn of a revolutionary new era in astronomy, where interstellar objects transform from rare curiosities into, critical scientific targets that could reshape our understanding of galactic evolution and cosmic chemistry. Robert Jedicka from the University of Hawaii estimates that technological advances, particularly the upcoming full operation of the Vera Rubin Observatory with its revolutionary LSST camera, promise to dramatically increase detection rates, potentially allowing astronomers to study dozens of interstellar visitors annually within the next decade. This technological revolution will create an unprecedented catalog of interstellar objects, providing statistical samples large enough to offer meaningful insights into galactic dynamics, planetary system formation processes, and the distribution of complex organic molecules across different stellar environments throughout our galaxy. Mark Norris from the University of Central Lancashire predicts that this growing database will reveal patterns in interstellar object populations that could answer fundamental questions about stellar evolution, planetary ejection mechanisms, and the chemical evolution of the Milky Way. As astronomers continue to unravel the mysteries of 3Y Atlas and prepare for an influx of future interstellar discoveries, humanity stands at the threshold of a new cosmic perspective, one that will fundamentally transform our understanding of our place in the universe and the evolutionary history of our galactic neighborhood, potentially revealing whether we truly are alone or part of a larger community of cosmic civilizations. As 3I Atlas continues its mysterious journey through our solar system, it carries with it questions that could fundamentally alter humanity's understanding of our cosmic neighborhood. Whether this ancient wanderer represents exotic natural phenomena or, something far more extraordinary, the implications are honestly staggering. The coming months will be crucial as this interstellar visitor approaches its closest encounter with our sun, potentially revealing secrets that have traveled billions of years to reach us. Keep following InnoVision Tech for the latest updates on this developing cosmic mystery. Like, share, and subscribe.